All right, today we're going to continue looking at 6.1. So yesterday we did multiplying monomials, and we had 3 different rules we looked at. We had a rule for when you multiply 2 things with the same base. What do you do with the exponents? And then, like in example B here, what would you do with them? And how would you combine them? Yep, add the exponents. Example A, that was another rule we did. That's a power raised to a power. What do you do with the exponents when you have that? You what?
Multiply.
Yep, multiply. And then when you have a product inside the parentheses to a power, you raise each thing in the parentheses to that power. And that's the one we just did. Okay, what we're going to look at today is dividing. Okay, how do we divide monomials? All right, so this part, we're just going to read this. You don't have to write this part down. But remember, when you have a fraction and you have the same factor in the top and in the bottom, okay, it cancels out. Okay, so what do I mean by that? So let's say you had something like 3 times 5 over 12 times 3. Okay? Whenever you multiply 2 things together, those 2 things are called factors. So the 2 factors in the top are 3 and 5, and the 2 factors in the bottom are 12 and 3. Is there a factor that's in the top and in the bottom?
Yes.
Yeah, which factor is in both the top and the bottom?
3.
3. So what ends up happening is, because it's in the top and the bottom, it cancels out. And the answer is just 5 over 12. Okay? As long as you have the same thing in the top and the bottom as factors, they cancel each other out. Now that doesn't work with addition. If you had something like this, you can't cross the 3's out there. That doesn't work. Okay? These are not called factors. Okay? These are terms because they have an addition sign in them. So if you wanted to do a problem like this, you just have to do it the way it is. 3 plus 2 is 5. 3 plus 9 is 12. And the answer is 5 over 12. Don't cancel the 3's and just say it's 2 over 9. That doesn't work. All right, but with multiplication, it does. All right, so let's use that. Actually, here's another example. 12 over 15. Right? So you do this. This is how you reduce fractions. You can break 12 up into 3 times 4. You can break 15 up into 3 times 5. There's a 3 in the top and a 3 in the bottom. So 12 over 15 reduces to 4 over 5. That's how you reduce fractions. Cancel out. Well, we're going to do the same thing with letters. Okay, so let's look at an example. Okay, we're just going to do this together. So just kind of watch me do it. What does x to the 5th mean? Like if you wanted to write that out for someone that didn't understand this 5.
X times X times X times X times X.
Yeah, it means just x times x. You're going to write that 5 times. So there are 5 factors in the numerator. They're all the same, an x, an x, and an. But there are 5 of them. Okay. How would you write the bottom out?
X times X.
X times x. All right. Now, is there anything that's being multiplied together in the top that also appears in the bottom?
Mm-hmm.
Yeah, what?
The X.
Yeah, so there is an x in the top, and there's an x in the bottom. Anything else that appears in the top and the bottom?
A second X.
Yeah, there's a second x. Yep. That's gone. That's gone. So if you multiply together what you're left with, what's x times x times x? X to the 3rd. Now look back at the original problem. Your original exponents were a 5 and a 2. Anybody think what you can do with 5 and 2 to somehow get the final answer that's a 3?
Subtract.
Yeah, subtract it. And that's what we're going to look at. Okay, we subtract them. So rather than having to write it out like this, especially if you had like x to the 35th divided by x to the 14th, we don't want to write x times x 35 times. Okay. That was a different one I did, but I changed it. It's actually. We basically just did that. All right, let's try this one. Y to the 5th divided by y cubed. Okay, I just want you to tell me how can I write the top?
Like y times y times y times y.
Yeah, we'll just write y times y times y. We'll do 5 times. Okay, how could we write the bottom?
Y times y times y.
So y times y times y. And now we look, is there anything in the top and the bottom that can cancel out? Yeah, how many y's does the top and the bottom have in common? 3, right? We can cancel 1, 2, 3 from the top, 1, 2, 3 from the bottom. You can't cancel any more than that. That's everything that was in the bottom. And all you're left with in the top is y times y, which is what?
2y.
That would be y plus y.
Oh, to the second power.
Y to the 2nd power. Yep. Or y squared. And again, how could you get 2 as your exponent when the original ones were a 5 and a 3?
Subtract.
Yep, you could subtract them. All right. Let's try this one and see what happens. So I'm just trying to show you some different things that can happen. Then I'm going to give you the rule, and that's what I'm going to have you write down on your notes in a second. Okay, so for this one, how many x's are in the top?
3.
3. How many x's are in the bottom? 7. Okay. How many x's can I cancel out from the top and the bottom at the same time?
3.
I can cancel 3. 1 there, 1 there, 1 there, 1 there, 1 there, 1 there. So look at what happened this time. The x's that are left, where are they in the fraction?
The bottom.
They're in the bottom. And the reason they're in the bottom is because you started with more in the bottom than you had in the top. Wherever you start with more, that's where they're going to be left. You start with more in the top, the final answer is in the top. Okay? Start with more in the bottom, final answer is in the bottom. So everything canceled from the top, but we gotta leave something there. So what number do you think we're gonna put there?
4. 1.
Because everything canceled out, we're gonna just put a 1. Yep. And what's x times x times x times x?
X. Or x to the 4.
X to the 4th. Okay, that's the answer to that one. Now let's try this. We did subtraction before, right? We did 5 minus 3, and we got 2. What happens if you do 3 minus 7? What's 3 minus 7 give you?
-4.
-4. Just put that up here for a second. Those two things are exactly the same thing. The only thing that a negative tells you on an exponent is negative means the answer is in the bottom. That's what the negative tells you. And we're gonna practice more. Like let's say I had x squared over x to the 5th. What's my base on that one?
5. Oh, no, x.
My base is x. And now let's subtract the exponents, because we're dividing, that's what we're supposed to do. 2 minus 5.
3.
-3. So what did I just say that negative really tells you?
The answer's on the bottom.
It tells me the answer should really go in the bottom of a fraction. Okay? That's what a negative exponent means. I think we get into negative exponents a little more tomorrow, but that's just kind of a preview of what's coming up because it ties in with division. Okay? All right, and I think I have one more. M to the third divided by m to the third. Where are there more m's this time? The top or the bottom? It's equal. Okay, so let's see what happens. M times m times m over m times m times m. How many m's can we cancel from the top and the bottom? 3. One from the top, one from the bottom. Top, bottom, top, bottom. So there's nothing left. We basically divided two things that were the same. What do you get when you divide two things that are the same? 1. Yep. So dividing two things that are the same, you get 1. If you start with more x's in the bottom, the answer ends up at the bottom. And if you start with more x's or y's, whatever the letter is in the top, the answer ends up in the top. All right. So that subtraction thing is how we're going to figure out where our answer is supposed to be. So let's write that down. So this is how you divide two monomials. So right at the top of your guided notes, it says to divide two monomials with the same base. Okay, you're going to subtract your exponents. And we're going to remember to always put our answer where we had the larger exponent. If the larger exponent was in the bottom, the answer is going to go in the bottom. If the larger exponent was in the top, our answer will go in the top. If we do it this way, we can kind of avoid having negative exponents today. As long as we just put our answer where it's supposed to go. Yeah. Yeah. Just sign out. Okay. So it says put your answer where you had the larger exponent. Can someone remind me one more time? What happens if the two exponents are equal? What do you end up with as an answer? So like that last one we did, m cubed divided by m cubed. Right. If you don't have a larger exponent because they're equal, that's kind of a special case. The answer comes out to 1. Okay. Does everybody have that rule? Okay, so now what we're going to look at is how does this rule fit into like the rules we learned yesterday? Right, so that's going to be the last thing that we're going to write down for like steps today. So we'll practice a few more, and then we'll get into combining it with the rules from yesterday. Okay, so first, look at your fraction. Where is the larger exponent? Top or bottom?
Top.
Top. So the answer to this problem is going to be in the top. What's going to be the base?
X.
It's going to be an x. And what's the calculation for figuring out my exponent?
Subtract.
Yeah, we're going to subtract. And remember, so we can avoid negatives for today. I always want you to subtract larger minus smaller. Okay. So we know it's in the top. What's the larger exponent?
8.
8. What's the smaller? 5. And what does 8 minus 5 give me? 3. So my final answer would be?
Cubed.
X cubed. Perfect. Okay, so a lot quicker than having to write out x times x 8 times, and then x times x 5 times, and then crossing them out. We just do this subtraction, and it's a lot quicker. Yeah. Yep, just sign that form. All right, let's try this one. Y to the 9th divided by y to the 9th. Right. We don't even have to think about it. That one's going to automatically be 1 because you are dividing two things that are exactly the same. Okay. Right. Let's look at 1C. What's my exponent on the z in the top? Because they didn't write it.
1.
It's a 1. Okay, where do we have more z's right now? In the top or the bottom? Bottom. Then that means my final answer needs to go in the bottom of the fraction. So make a fraction bar, and you're going to write your answer in the bottom. What's my base?
Z.
Z. And remember, so we avoid negatives. We already put the answer in the bottom. We have to subtract the exponents larger minus smaller. What's the larger exponent in this problem? 5. What's the smaller? 1. Okay. So what do we end up with in the bottom of the fraction?
Z to the power of 4.
Yep, z to the power of 4. Now you can't leave the top blank like that. You got to put something there.
A 1.
Yep, you just put a 1 there. And that's how you do it.
Isn't it -4?
Because we put it in the bottom, that took care of the negative.
It's like the same thing. As
Yes, it would be exactly the same thing as this.
So if we put either or on a test, it would still be accurate?
As long as the directions didn't say write your answer with positive exponents. This problem didn't say that. So if you wrote this on a test or you wrote that on a test, they mean exactly the same thing. And with those directions, you'd get it right. You will see some problems on the test, though, that say write your answer with positive exponents. Yeah. All right, so why don't you guys try 1D? Okay, try that one on your own. So it's 4 divided by 4 to the 5th. All right, so see if you can figure out where your final answer is going to go. And even though this one is a number, so you can simplify it when you're done. It's not a letter, so you can actually get a number as the answer. Just leave it kind of like we did the last problem, and we'll use a calculator to finish it up. Let's take a look. First thing I'd want to make sure we do is know what the exponents are if they're not written. What is the exponent that should be in the top?
1.
Right, should be a 1 on. Okay, so now we're going to figure out what our answer is. What is the base in example 1D? 4. Now, when we write the 4, are we going to put it in the top or are we going to put it in the bottom?
Bottom.
Right, why does the 4 go in the bottom?
That is the exponent on the bottom is big.
Right, there are more 4s in the bottom. There's 5 of them. There's only 1 in the top. So wherever the bigger exponent is, that's where the base goes. Okay, so it's going to be a 4. Now the exponent, what operation do we use when we're doing division? We take these two exponents and,
Subtract.
yep, we're going to subtract them. And remember how we always subtract them? This is so we can avoid the negative. We already put it in the bottom. That takes care of the negative. Now we're just going to subtract larger minus smaller. Okay, what's the larger here? 5. And what's the smaller? 1. And you can't leave the top blank. We got to put something.
Yeah, but a 1.
We got to put a 1. Okay. So final answer. What goes in the bottom?
4 to the power of 4.
Yep. Just a coincidence. They're both 4s. 4 to the power of 4. And if the directions just said simplify, you've technically, I mean, you have simplified it. You haven't simplified it as much as you could. This is small enough, I think we could do it out. 4 to the 4th power. Does anybody know what 4 times?
256.
Yep, comes out to 256. That's the final answer, as simplified as you can do it. Now, if the bottom was like 4 to the 30th power, that's way too big. Okay, that's going to be a huge number. We wouldn't do that out. If you had a question on a test, if you should do it out as 256 or just leave it, you can always ask me and I'll tell you. Okay. Is there any question on it? All right, so now we've got to look at how do we combine this rule with the rules we had yesterday. There's a certain order that we try to do the rules in to make it as easy as possible. Okay, and I'm going to show you what that order is. So these are going to be the steps when dividing monomials. You may not have every step in every problem, okay, just like PEMDAS. PEMDAS doesn't mean every single problem is going to have parentheses, exponents, and everything. Okay, so first of all, do you guys already have all these little reminders on the side?
Yeah.
Okay, so those are just general reminders. Okay, the first one, we're going to be keeping the base the same. Okay, whether you're dividing or you're multiplying, the base never changes. If you have a variable that doesn't have an exponent on it, you can put a 1. Okay, we've been saying that all along. And you should simplify numbers. So for example, don't leave something as 3 to the 2nd power. Put 9. Okay, that's small enough. We should do that out. Okay, so those are just kind of some general reminders. Okay, so rule number 1. The first rule that you always do, if it comes up in the problem, is the power to a power. Okay, remember, that's where you're kind of taking that exponent on the outside and you're distributing it to each exponent on the inside. So rule number 1 is just like this problem we did in the warm-up. Right here. That's rule number 1. Applying that exponent to each exponent on the inside. Okay, so after you do power to a power, okay, the next rule you're going to do, rule number 2, is we're going to simplify any whole numbers. Whole numbers, those are the big numbers, not the exponents. Okay, I mean something like this. Like if we had 2x cubed divided by 8x to the 5th. The whole numbers here are 2 and 8. And you can simplify 2 divided by 8. Like if this was a fraction, what does 2 over 8 reduce to?
4. No. 1 over 4.
1 over 4. That's what I mean by rule number 2. Simplify, those are the big numbers, not the exponents, those are the little numbers. The big numbers that are in front. If you can. Right? Now if you had something like 3y to the 5th over 4y to the 2nd, can you simplify the fraction 3 divided by 4? Does it reduce?
No.
No. 3 divided by 4 doesn't reduce. 3 divided by 6 would reduce. That'd be 1/2. But 3 divided by 4 doesn't. So you might not always have rule 2. Okay, but that's the next step. Okay, the third step is we're going to multiply any monomials that are on the same level. Okay, that would be something like, let's say we had 2x squared times x cubed times y. And then we had 3 times x times y to the 4th times y. What I'm going to highlight in green is one level. That's the top level. And what I just highlighted in like the blue color, aqua color, that's the bottom level. So if I was doing this problem, first thing I would do is I would block the bottom and just look at the top. I have a 2, x squared, x cubed, and y. What can you combine in the top in that problem? There's only 2 things that would combine, just in the top.
The x's.
Yeah, you can combine the x's. So we would multiply those together by adding the 2 and the 3, and we would say x to the 5th when we put them together. Now, look at the bottom level separate. Is there anything in the bottom level that you can combine together?
The y's.
Yeah, you can combine the y's. When you combine y to the 4th with y, what would you get in the bottom for y?
Y to the 5th.
Exactly, you would get y to the 5th. I'm not going to go through and do that whole problem, but that's what I mean by step 3. Simplify what you can just in the top, and then just in the bottom. Now step 4, this is the step we learned today. We're going to simplify things on different levels, okay? Something in the top and the bottom. That's where the subtraction comes in. So the trick that I'm giving you today to avoid any negative exponents is to always put the answer where the bigger exponent was. Now, if you look, I wrote something down on the right. I want to look at that in a second. If I have x squared, x cubed, and I divide by y squared, can I combine those together?
No.
No. Why not? Why can't I just do 3 minus 2 and combine them?
There are 2 different bases.
They're 2 different bases. You can't combine them when they're 2 different bases. What if I had something like x cubed y to the 4th over y squared times x to the 1st? If I want to combine these first 2, could I just do 3 minus 2? Why?
Bases are different.
Yeah, these first 2, they're not lined up right. If I have x first in the top, what do you think should be first in the bottom?
X.
Yeah, the x's should both be in the same column. And then if y comes second in the top, what do you think should come second in the bottom?
Y.
Should be y. Yep. So we always have to make sure when we do step 4 that we line them up in columns. That's what I'm trying to get at here. This is a problem that looks good to me. Everything is lined up nicely in columns. The numbers are in columns, the x's are in column, and the y's are in a column. The one on the other page, it's not lined up right. You got x's and y's in the same column. That's not good. It seems like a lot of steps, but remember, you don't have every step in every problem, right? So most problems don't have every single step. All right, and then step 5, if we need to, sometimes this doesn't even happen, but if there's any fractions we need to reduce at the end, we can reduce them. For example, if we end up with like 3/9, we're going to make it 1/3. If we end up with 4 divided by 2, we could just make it 2. Sometimes that doesn't even happen. Depends. Depends on your numbers in the problem.
It's actually simplifying.
Step 5? Yeah, it's like simplifying. Yeah, we're just reducing, simplifying any fractions that we can. All right. So that's kind of the order of all the rules that we've learned so far. So let's try a few examples. See what we can do. Okay, so let's try example 2a. Let me rewrite it in case you can't read it. It's v to the 5th times v cubed over v squared. Okay, and let's look at our rules. Do we have parentheses in this problem with an exponent on the outside of them?
No.
No, then we don't have to worry about rule 1. Do we have any numbers in front of the variables, like 3/4 or something that we could reduce? No. So we don't have to do rule 2. Okay. Do we have things on the same level that could be combined together?
Yes.
Yeah, we do. Okay. Is there anything on the bottom level we need to combine?
No.
No. There's only one thing in the bottom, so for now that just stays the same. But in the top, we have v to the 5th times v to the 3rd. What's going to be the base when we combine what's in the top?
V.
It's going to be a v. And what's going to be the exponent?
15. No. 8.
8. Add the exponents together. Okay, 5 plus 3 gives me 8. Okay, so that's step 3. Now step 4. Divide monomials on different levels. Do we have the same letter in the top and in the bottom?
No. Yes.
What do we think? I heard yes and I heard no.
Yes.
Yes, we do. What letter do we have in the top and the bottom?
V.
Yep, V. Okay. Now, where do we have more V's? Do we have more? Is the bigger exponent in the top or the bottom?
Top.
Top. So where's my answer going to end up then?
The top.
It's going to end up in the top because there's more in the top. It's going to be a V. And you don't have to give me the exponent. I just want to know what's the calculation for the exponent.
8 minus 2.
Always the bigger minus the smaller. And put the answer where the bigger number is, which is in the top. So I don't even need a fraction bar because it's not going in the bottom. Okay. So what's going to be my exponent on B? 6. And that's my final answer. V to the 6th power. So this problem didn't have rule 1, didn't have rule 2, didn't have rule 5. All it really had was rules 3 and 4. That's all it had. Yes?
Why did you write it like 2 times?
I just thought it was a little fuzzy.
Oh.
I just didn't know if people, when I had it bigger, it looked kind of fuzzy to me up close.
Yeah.
Any question on that one? All right, let's look at this one. All right, so again, I'm going to put the, I'll leave it big so you can copy it, but then I want to put the rules back up so we can see those at the same time.
Is that 2 times 6 or is that 2 to the power of 6? On the bottom.
That's 26.
Oh, that's 26?
Yeah. So negative 13 x to the 8th times y divided by 26th x to the 4th y to the 5th. All right, let's look at our rules. Okay, do we have any parentheses and we have an exponent on the outside?
No.
No, so we don't have rule 1. do we have any big numbers in front of letters that we could simplify?
Yes.
Yeah. So what I'm going to do is just simplify that. Let's leave the x to the 8th, leave the y, leave the x to the 4th, and leave the y to the 5th for now. What number goes into 13 and 26? Yeah, 13. Okay, the negative is going to stay right where it is. How many times does 13 go into 13? Once. How many times does 13 go into 26?
3 times.
That would be 39. 13 goes into 39 3 times.
Yeah.
How many times does it go into 26?
2.
2. Okay. So that step is all you have to do. If this was like 13 over 27, I wouldn't have done anything because I can't reduce 13 over 27. But I can reduce 13 over 26. So any question how we got the 1 and the 2? Okay, so step 2 is done. Step 3, multiply monomials on the same level. Is there anything in the top level that I can combine together?
No.
No. I have a number, an x, and a y. None of those are like terms. How about anything on the bottom level? No. I have a number, an x, and a y. I'd need to have 2 of the same letter on the same level to combine them. Okay, so I don't have step 3 this time. Step 4. Now we're going to divide the monomials on different levels. Do we have the same letter on different levels?
Yeah.
Yeah, we do. So what I do is I usually draw these lines because it just helps me to kind of separate everything. You don't have to. Is everything lined up? Like, do I have numbers in a column, x's in a column, y's in a column, or do I need to swap things around to fix it?
No, it's good.
It's good. Numbers, x's, and y's. It's perfect. So remember now we're going to subtract to simplify those. The first column is done. That's negative 1 over 2. We did that right away. Okay, now we're going to treat it like 2 little problems. X to the 8th over x to the 4th. Where do we have more x's? Top or bottom?
Top.
Top. So where is the x going to end up going?
Top.
Top. Now subtract the exponents on the x's. What's the larger exponent?
8.
What's the smaller?
4.
And what's 8 minus 4?
4.
4. So that goes there. Before we do anything with the y's, let's make sure we know what our exponents are. We're missing the exponent on the y. So what does it say we can put there?
Put 1.
We can put a 1. Okay. Where do we have more y's?
At the
Top or bottom?
bottom.
Bottom. So this time the y is going to go,
At the bottom.
it's going to go in the bottom. Yep. Okay, and now subtract your exponents. What's the larger one?
5.
And what's the smaller one?
1.
And what's 5 minus 1?
4.
4. And there you go. When you're done your problem, you shouldn't see the same letter appearing more than once. If you do, then you didn't combine what you could have. Okay. So I see the x appearing once, I see the y appearing once. That's good. That's it. Any question on that? It takes a little bit of practice, but I think if you break it down into littler problems, that helps you solve the bigger problem. Okay, so now on the back of the guided notes. So it says, when you have a fraction to a power, and then you guys have a blank line to write this in, you want to write down everything that's underlined right there. Okay. When you have a fraction to a power, it says raise both the numerator and the denominator to the power. So it's not really another rule. It's really kind of like one of the rules we already done before. We just haven't seen it applied to a fraction. Okay, so I have an example of what I wrote up above. I'm taking this entire fraction and raising it to the second power. To do that, you take what's in the top and you raise that to the second power, and then you take what's in the bottom and you raise that to the second power. That's how you do it. Now, look at what's in the top. That's a rule we did yesterday. How do you raise 4x to the second power? This is like rule number 1. This is when you have the number on the outside of parentheses and you apply it to what's inside. So anyone think they could tell me how that top would simplify?
You would just do both.
So you'd have 4 to the...
Power of 2.
Yep,
And then x to the power of 2.
exactly. 4 to the power of 2, x to the power of 2. Perfect. And now the bottom, 3 squared. Well, I think I actually used that as an exact example right here. We don't want to leave it as 3 squared. What should we simplify that as?
9.
9. Yep. And same thing with 4 squared. That's small enough we could do that one out. What's 4 squared?
16.
16. Good. That's how you would do that. Let's just try one more of those together. Okay, so it's not the example on your guided notes yet. Let's do 2y cubed over, 4. And I'm going to raise that to the 5th power. What would I write first, just to do the top?
Parentheses 2y, parentheses to the power of 3.
2y,
Oh wait, 2y to the power of 3, and then parentheses to the power of 5.
perfect. So you raise the top to the power, and then what would go in the bottom?
4
Anything else?
to the power of 5.
4 to the power of 5. Yep, that's your first step. Other than typing in 4 to the power of 5 on a calculator, there's nothing we can do in the bottom. So we'll do that in a second. But now, how would I write the next step, kind of like we did right here? How am I going to apply this power of 5?
2 to the power of 5.
So 2 to the power of 5. And now be careful with the next part. It's y cubed
Doesn't it cancel it out?
to the power of 5.
Isn't it y15?
Yes.
The power of 15.
Y cubed to the 5th power is y to the 15th. And then the bottom is 4 to the 5th. So the only thing I would do with that is now just use my calculator, figure out what 2 to the 5th power is and what 4 to the 5th power. 4 to the 5th power it's not actually that big. Hey, it's 1,024. So that's small enough. We could still do that out. And 2 to the 5th power is 32. All right, so now I think, it's actually just like the ones we just did. All right, let's try example 3A. Okay, so we have a fraction raised to a power. So follow the rule. Raise the top and the bottom to that power. and we put it in parentheses. Okay, so if I start to simplify that, what's going to go in the top?
Negative x to the power of 3.
Negative x to the power of 3. And what's going to go in the bottom?
4 to the power of 3.
4 to the power of 3. And the only thing we really need to do there is simplify the bottom. 4 times 4 times 4. Does anybody know what 4 times 4 times 4 is? Not 4 times 3. So 4 times 4 is 16.
Wouldn't it be
And then
64?
16 times 4.
Yeah, 64.
64. Yeah. Right, so that was actually a little bit easier fraction to a power. It wasn't as complicated as the ones I even did up there. Yeah. Any question on that one? So I'm just trying to show you all the different kinds of problems you could have. Right, let's try this one. 6x cubed divided by, that's a 7, and you're squaring it. Okay. So what's the first thing that we're going to write in the top?
6 to the power of 2.
Can you tell me so if you follow that step, raise the numerator to the power. Okay, what's my numerator?
6.
Part of it.
6 to the power of 2.
So looking at that fraction, can anybody tell me what is my numerator?
6x to the power of 3.
So 6x to the power of 3. And we're going to raise that entire thing to what?
To the power of 2.
To the power of 2. Then we're going to break it down and start doing what you were saying. What about in the bottom?
7 to the power of 2.
7 to the power of 2. So let's simplify the bottom. What is 7 to the second power?
49.
49. So 49. Now, this is a product raised to a power. So what are we going to write down to do out the 2 on the outside of the parentheses?
6 to the power of 2.
6 to the power of 2 times
X to the power of 5.
No, it's not. You're not doing this. That's x to the power of 5.
6.
You're doing x cubed, and you're squaring it, which is x to the what?
6.
Yeah, x to the 6th. And now we can simplify what's in front of x to the 6th. What's 6 squared?
144.
That's 12 squared.
49.
That's 7 squared. What's 6 times 6?
36.
36. 36 x to the 6th over 49. Okay, this takes a little practice to get good at them. Any question on that? All right, so I'll have you guys try. Got a couple extras I did. Let's see what we got. We got that one, and that one. All right, let's try. Let's try maybe 3 and 4. Okay, so we'll skip the 1 and 2. You got bigger boxes for the 3 and the 4 anyway. Okay, so see if you can figure out 3 and 4. We'll go over them, and then those will be the last 2. I'm going to give you guys a few minutes to try those. So the one on the left says y squared times y to the fourth over y cubed. And the one on the right is 4y squared divided by 5, and you're cubing that entire thing. Okay, let's just look at the first one together. I'll still give people time to work on the second one. We have y's on the same level that can be combined. What do you get if you combine the y's that are in the top level, for example, 3?
Can you ask that again, please?
When you combine the y's in the top of the fraction, for example, 3, what do you get?
Y to the 6th power.
Yep. You get y to the 6th. Y to the cube, y to the 3rd is in the bottom. And where do you have more y's in that problem? Top or bottom?
Top.
Top. So your answer goes
That's top.
in the top. And what's the calculation to get your exponent when you're using a 6 and a 3?
There's like subtraction.
Yep. Which one goes first?
6.
Yep. Always the bigger one first. And what's 6 minus 3? 3. So that's what you should have gotten for the top one.
Wait, you don't go down to the fourth thing and do divide the stuff on different levels?
That's what we did right here. That was the only, actually there were 2 steps in this problem. That was, I think, step 1 or 2. And then what we did right here, the subtracting, that's step 4. Yep, because they're on different levels. All right, and the last one. When you have a fraction raised to a power, start by writing the top. And what power is the top going to get raised to?
3.
Yep, the 3rd. And what power is the bottom going to get raised to?
3rd.
That's how you have to do a fraction. You raise both of them to the 3rd power. Okay. Now, in the bottom, there's not really anything else we can do. Did anybody figure out what 5 cubed is?
It is 125.
Yep, 5 times 5 times 5. And how do we deal with this exponent of 3 on the outside of those parentheses?
4 to the power of 3.
4 to the power of 3, perfect.
And y to the power of 6.
And then y to the 2nd to the 3rd. Power to a power, multiply them, perfect. Y to the 6th. And what's the only thing left that I could simplify that's in the top?
4.
Yeah, 4 times 4 times 4, and I think we just did that. What did 4 times 4 times 4 come out to? 64. So your final answer should be 64y to the 6th over 125. All right. So homework for tonight is the worksheet on 6.1 part 2. And remember, we will have a review day on Thursday. So tomorrow will be the last day of any new material. I will also be after school on Thursday if you need any extra help with anything. And if there is anything you need to finish up from term 1, it pretty much has to be done by tomorrow morning. 8 a.m. is when I have till enter my grades. Okay.